Hi, welcome back. In our previous lesson, we looked at practice questions on equivalent and compensating variations. Today, we'll be moving on to the life cycle model. So the analysis of saving decisions rests on the life cycle model, which says that people's consumption and saving decisions during a given year are the outcome of a decision-making process that takes into account their lifetime economic circumstances. In other words, the amount you save each year depends not only on your income that year, but also on the income that you expect in the future and the income you had in the past. So, in terms of utility, the life cycle model assumes that the amount of utility that an individual obtains over the course of his lifetime depends on the amount to be consumed in each period of his lifetime. So, just like we did previously, we can also use budget constraint and indifference curve to understand the concept of the life cycle model. We are going to begin with intertemporal budget constraint. The budget constraint, as we know, shows the various options available to an individual. In this case, the options are the possible combinations of present consumption and future consumptions available to that individual. So, because the budget constraint in the life cycle model shows the trade off between consumption levels in different time periods, it is often referred to as the intertemporal budget constraint. Now we are going to use a figure to understand this concept more. But to do that, let's start with a consumer named Samuel who expects to live two periods, period 0 and period 1. Now his period 0 is his present period and period 1 is his future period. In our figure, we will call the consumption in period 0 as present or current consumption and represent it as C0 on the horizontal axis. So future consumption will also be represented on the vertical axis, and this is called C1. If someone earns I0 in a current period and knows that his future income will be I1 dollars, then the first option that is available to someone is to consume all of his income just as they come in. So this means that someone will consume I0 in the current period and then I1 in future. So this bundle is called the endowment point, which is represented as point A on this figure. So the endowment point is the feasible consumption bundle if the individual makes no trade-off between his present consumption or future consumption. Now, in other words, it is the bundle that the individual can consume if they neither save or borrow, because consumption in each period is exactly equal to the income in that period. Now, apart from this endowment point option, another option that is available to someone is to save part of his current income so that he can consume more in the future. So if someone saves S dollars in the current period, then his current consumption is going to be C0 being equal to I0 minus S. So this means that his current consumption is the income that he gets in his current period minus the amount that is saved. So the rest is what he consumed. If he invests his S amount of savings in an asset with an interest rate equal to I, then his future income is going to increase by this amount. So if we rewrite this into the next equation, this S simply represents the amount he saved in the current period, and the interest rate multiplied by S is simply interest he earned on the savings. If someone decides to save S amount in the current period, his future income is going to increase by this amount. On our figure, this is represented by moving S dollars to the left, which we have seen here, moving S dollars from I0 to this point. This represents a decrease in current consumption. In the same case, this movement to the left is also accompanied by a movement above. If someone saves S, then his future income increases by this amount, moving him up to point D, representing an increase in his future consumption. This point D on Samuel's budget line simply represents the fact that he saved an amount in his current period, which increased his future consumption. Instead of saving, Samuel can also decide that he will consume more in the current period, which means that he's going to borrow an amount of money against his future income. If you are looking at this option and assume that Samuel borrows B amount in the current period at the same interest rate I, then his future consumption is going to be reduced by this equation here, which is the amount he borrowed plus the interest that is accrued on that amount borrowed. On our figure, this is represented by Samuel moving B dollars to the right, represented here, and then also moving 1 plus I multiplied by B down to our budget line F. What this point F is telling us is that if someone increases his current consumption beyond his current income, then he will have to borrow against his future income. By repeating this process for various values of savings and borrowing, we can determine how much future consumption is feasible, given any amount of current consumption. In this process, we can connect point A, point D, point F, and any other point generated in this way to derive our intertemporal budget constraint B1. This is all that we have on the first part of our lesson on the life cycle model. In our next lesson, we are going to focus more on the intertemporal budget constraint. If you enjoyed today's lesson, consider subscribing. Thank you.